Okay, students, so now what we're going to talk about is inscribed angles, all right? What we've done a lot in the past is talked about central angles. Central angles, vertex are in the center of a circle, hence the name central angles. Inscribed angles, well, let's just start doing the notes and we can tell you exactly what those are, all right? So, an inscribed angle of a circle has its vertex on the circle and is formed by two chords or secant lines of the circle. All right, so let's go ahead and just draw it right now. What that means is boom, and then really what we're gonna, it can technically keep going. We'll call this A, B, and C. So remember, just some fun facts is A, B, and AC, those are chords. All right. Their endpoints lie on the circumference of the circle. That's what a chord is. Furthermore, A is on circumference. All right. So, an intercepted arc is the next one. Is an arc on a circle whose points lie between the rays of the given angle and the vertex of the inscribed angle. All right, so then this is the intercepted arc. So we've actually been talking about arcs, arc measures, arc lengths, different things. And then this would be a fun time just to say, remember, arc measure. We have two things that sound incredibly similar. We have arc measure, which is in degrees. We have arc length, which is a distance, such as like inches, centimeters, feet, so on and so forth. All right. So this is not in the iBook right here, but let's think about it, all right? So let's make this a little bit bigger. All right, let's compare and contrast a central angle and an inscribed angle, all right? So let's just focus on, we'll call this AB. All right, we have some intercepted arc AB. All right, well, if this is circle C, all right, that's a central angle. Or we could have point D, and this is an inscribed angle. All right? And then we'll even talk about that where angle D is inscribed. Angle C is central. All right. I'm going to tell you right now, this is kind of going to be a punchline, a little foreshadowing. You're going to have to stay tuned to find out more. But the measure of angle C does not equal the measure of angle D. All right, there is actually a relationship that goes on between them. All right, so the angles don't have the same measure, but maybe you can tell by looking at the picture what the relationship will be. All right, now let's see how smooth I am. Let me see if I can pull this. Oops, I don't want my email. Let me see if I can pull. Yeah. I rate my smoothness a C-. All right. So we have a gizmos right now. All right. I like to do gizmos every now and then. Make sure we're logged in if you're doing it. All right. So in intercepted angles gizmo, we will explore the relationship between inscribed angles and the arcs they intercept. All right. So we want inscribed angle 1 selected, which it is. All right. And we're going to select the show angle measure tool. All right, so let's see what this angle measure is for this intercepted or this inscribed angle. All right, right now it's 37.5. We'll keep it right there. All right, so 37.5 degrees Fahrenheit. All right, Now let's select the other angle tool and let's actually just form a central angle. Boom, boom, oops, boom, boom. Okay, so this green angle is an inscribed angle. Now we have this central angle in like this maroonish, purplish color. Notice how that measures 75 degrees. Right? And then let's show arc measure tool as well, just for fun. So boom, we're gonna do arc BC, which is 75 degrees. Technically we should have already known that, because remember, central angles equal intercepted arcs. Alright, that's something we've already known. The central angle has the same measure as its arc. And then if I play around with this, well, nothing really changes, alright? The angles are still staying the same. That's kind of interesting. No matter where I pull this vertex A on the intercepted arc, notice how it's always 37.5 degrees. That's kind of pretty interesting and pretty important. Alright, now we got some nice crisp clean numbers. Alright, how does the inscribed angle and central angle compare? Well, remember, the inscribed angle was 37.5 degrees. The central angle was 37 degrees. Oops, I messed up. I meant to say 75 degrees. Oops. Alright, well, people, I'm going to write IA for inscribed angle is half the central angle. Alright, that's it. Or you could say central angle is double the distance. Alright, and that kind of makes sense if you think about it. Where like, let me see where I could draw this at. We draw this, alright. This is the way I kind of like to think about it unofficially. But this is the radius. This is another radius, or the diameter, so it's like double. The vertex is twice the distance from the intercepted arc. So that's one way you can think about why this works the way it does. Similarly, inscribed angle is 37.5. The arc measure was 75 degrees. So you could say inscribed angle is half arc measure. All right. That's all we'll do